Section 6.7 is on recursively defined sequences. Your learning targets are that you will be able to write terms of recursively defined sequences. You will be able to write recursive rules for a sequence. You will be able to translate between recursive and explicit rules, and you will be able to write recursive rules for special sequences. For your core concept, you have a recursive rule for your arithmetic sequence, which is a sub n equals a sub n minus 1 plus d, where d is the common difference. And for geometric, a sub n equals r times a sub n minus 1, where r is the common ratio. For example 1, you're writing terms of recursively defined sequences. So you need to write the first 6 terms of each sequence and then graph them. So what's nice about this is that it tells you the first term. So we know that a sub 1, our first term, is 3. Then to find our second term, the formula here says take your previous term. So if I'm finding my second term, I'm going to plug in my first term, which was 3, and then add 5. So that gives us 8. So then to find my third term, I'm going to take my second term and add 5. So this gives us 13. To find my fourth term, I take my third term and add 5, and this gives us 18. To find my fifth term, I take my fourth term and add 5. So this gives me 23. And then finally, for our sixth term, we take our fifth term and add 5 to get 28. So now we have our first 6 terms and we want to graph the sequence. So I'm going to make a kind of like a sideways XY table up here. So we have term 1 is 3, term 2 is 8, term 3 is 13, term 4 is 18, term 5 is 23, and term 6 is 28. So now we're going to go ahead and plot these points. Remember, once you have the points plot, you do not connect them. So this was following like an arithmetic pattern. So now we're going to look at B, which is following a geometric pattern. So again, it gives us our first term. Our a sub 1 is 0.5. So then to find a sub 2, our formula here is saying 2 times a sub n minus 1, meaning the previous term, which in this case was 0.5. So 2 times 0.5 is 1. To find our third term, we're doing 2 times 1, which gives us 2. Our fourth term would be 2 times 2, which is 4. Our fifth term is 2 times 4, which gives us 8. And then finally, our sixth term would be 2 times 8, which would be 16. So then again, to graph these, I'm going to make my sideways XY table right here again. Our first term is 0.5. Our second term is 1. Our third term is 2. Our fourth term is 4. Our fifth term is 8. And our sixth term is 16. So here are our points for this sequence. And again, you do not connect the points. Example 2 is writing recursive rules. So it says write a recursive rule for each sequence. So when you're writing a recursive rule, you have to state your a sub 1, and then you state your a sub n, how you're getting the next term. So in this sequence, our a sub 1 is -8. So that's how we start our recursive rule. And then we need to figure out what pattern is taking place here. How are we getting from one term to the next? And here we are adding 7. So this is arithmetic. So for the next part, for our a sub n portion, we're going to do a sub n minus 1. So what that means is for my a sub n, for my next term, I take the previous term, and then we're going to put plus 7, your common difference. So both of these combined are the recursive rule. So again, looking at over here for B, we need to state our a sub 1, and we need to state our a sub n. So looking at your sequence, your a sub 1, your first term, is 405. So we're going to state that a sub 1 is 405. So then we need to determine what pattern is taking place here. How are we getting from one term to the next? You might notice that you're dividing by 3. Again, dividing by 3 is the same as multiplying by 1/3. So 1/3 is our common ratio. So to write this formula, we have a sub n equals, our common difference goes first, 1/3 times a sub n minus 1. So this is meaning for your next term, you do 1/3 times the previous term. And again, both of these together are your answer. Example 3 is translating from recursive rules to explicit rules. So we are given a recursive rule here for the first problem. We have a sub 1 equals 9, and a sub n is equal to a sub n minus 1 minus 4. So this is a arithmetic recursive rule. So this -4 right here is our D, our common difference. So if you think back to when we were learning arithmetic sequences, your formula was a sub n equals a sub 1 plus the quantity n minus 1 times D. So we need to plug in our a sub 1 and our D into this formula. So we have a sub n equals 9 plus n minus 1 times -4. And then from here, we need to simplify this. A lot of you forgot about simplifying when we were doing this chapter, this lesson in chapter 3. So from here, you need to distribute the -4. So we have a sub n equals 9 minus 4n plus 4. And then your 9 and your 4 are on the same side of the equal sign. So those are just combining like terms. 9 plus 4 gives you 13. So I'm going to bring down my plus 13. So this, a sub n equals -4n plus 13, is the explicit rule for this recursive rule. So for B, we have a sub 1 equals 4.5 and a sub n equals 3 times a sub n minus 1. And this right here is our R, which is our common ratio. So this is a geometric sequence. And then we just learned about geometric sequences, and your explicit rule is a sub n equals a sub 1 times R to the n minus 1 power. So we just need to plug in the first term and the common ratio into this equation. And again, what's nice about this one is that we don't have to do any more simplifying. So our a sub 1 is 4.5, our common ratio is 3, and then we have our power of n minus 1. So a sub n equals 4.5 times 3 to the n minus 1 power is the explicit rule for this recursive rule. So example 4 is kind of the opposite of what we were doing in example 3. So now we're going to go from explicit to recursive. So in our explicit rule, for our first one, we have a sub n equals 6n minus 5. So this number right here in front of n, this is your D. So we already have our common difference. We need to calculate our first term. So what we're going to do is we're going to plug in 1 for n so we can calculate the first term of the sequence. So 6 times 1 is 6. 6 minus 5 is 1. So our first term is 1. So in writing our recursive sequence, again, we state our first term, And then for the second part, we have a sub n equals a sub n minus 1. And then now we bring in our common difference, so plus 6. And again, both of these are your answer for your recursive sequence. Over here, we have a sub n equals 4 times 3 to the n minus 1 power. Again, this number in here in the parentheses, this is your r. We do need to calculate our first term. So we have 4 times 3 to the 1 minus 1 power. 1 minus 1 is 0. 3 to the 0 power is 1. And 4 times 1 is 4. So this is our first term. So then we write our first term. So a sub 1 equals 4. And then for our second part, we have a sub n equals your common ratio, which is 3 times a sub n minus 1. So this is our answer here. Now, if you recall, looking back up here at the explicit rule, this 4 is also your a sub 1. So technically, you don't have to calculate it, but if you need to remember something for both of them, calculate your a sub 1 first, and then your common ratio or your common differences in the equation. Your arithmetic sequence does not give you a sub 1 in the formula, which is why you have to calculate it. Example 5 is now looking at another type of sequence. So we've mainly been focusing on arithmetic and geometric sequences. And so we can use recursive sequences to write rules for other sequences that are not necessarily adding or subtracting or multiplying or dividing by the same amount each time. So for our sequence here, we have -4, -5, -9, -14, -23, and -37. And we need to write a recursive rule for this. So if you look at the sequence, the pattern here is adding the previous two numbers. -4 plus -5 gives you -9. -5 plus -9 gives you -14. -9 plus -14 gives you -23. And then finally, -14 plus -23 gives us -37. So writing the recursive rule here is going to be a little bit different because now we need to state our first term, which is -4, and we need to state our second term, which is -5. So then we can finally state our a sub n, which is going to be, to find the next term, you're going to add the number 2 before to the number right before. So we have the 2 numbers before and 1 number before. So all 3 of these together are your recursive rule for this sequence. So then the next part is finding the next 3 terms. So we're going to do -23 plus our -37. So again, when you're adding negative and a negative together, your answer is going to remain negative. So -23 plus -37 is -60. So now we're going to do -37 plus -60, which is going to give us -97. And then last, we're going to do -60 plus -97, which is going to give us -157. So our next 3 terms are -60, -97, and -157.